This is worksheet 4, page 2. So continuing on with the review. In this case, guys, so we want to be able to determine the slope and y-intercept from each of the lines. So in order to do that, before we can do anything, we have to make sure everything is in slope-intercept form. So in case you need a refresher, oh boy. So slope-intercept form is y equals mx plus b. Y equals mx plus b. Because from this form, I can easily see my slope, which is m, and my y-intercept, which is the b part of it. So like for example, looking at 15, this is already in slope-intercept form because I have y by itself and I have my x term first. So from this, now I can actually look and see what my slope is and what my y-intercept is. So my slope, that's just the number before the x variable, looking in slope-intercept form. So in this case, the number before my x variable is -1/2. So that tells you that this line has a slope of -1/2. Now, when I want to find the y-intercept, well, that is just the last value. That's the plus b part of slope-intercept form. So in this case, my slope, or my intercept in this case, is -10. But remember, guys, when we write intercepts, that's going to be as an ordered pair. So if that's the y-intercept, I know my x value is 0. My y value is -10. Because the definition of y-intercept is the y value when x is 0. So again, moving on, so what's different between 15 and 16 is that 16 is not in slope-intercept form. So in order to get there, I need to get y by itself. So I'm going to divide everything by 2. So in this case, guys, the 2's are going to cancel. So that's just 1. 4 divided by 2 is going to be 2x. And then 12 divided by 2 is a positive 6. So now that I have this in slope-intercept form, now I can actually go and find my slope and my y-intercept. So my slope, again, was the number before the variable. So in this case, my slope is going to be 2. Or sometimes if you want to write 2 over 1, whatever works for you, both of those are fine. Both say they have a slope of 2. And then now I want to find my y-intercept. So that's actually the last part. That's whatever number is on the end. So as a y-intercept, I have an x value of 0, and my y-intercept is just at 6. Alright, same with 17, just like 16, is this one is not in slope-intercept form, so I need to get it there first. So the first thing I'm going to do is I'm going to get the x term out of there. So I'm going to add 8x to both sides. And in this case, my 8x is going to cancel, and I'm left with 4y equals 8x plus 4. And my last step to getting y by itself is just to divide by 4. And when we divide by 4, remember to divide each term by 4. So in this case, I'm left with y equals 8 divided by 4 is just 2. Keep the x. And 4 divided by 4 is just 1. So from this, now it's in slope-intercept form, so I can easily see what my slope and y-intercept is. So my slope, again, the number before the variable, that's going to be 2. And then my y-intercept is the plus b part, or in this case, the plus 1. So I am going to have a y-intercept at the point 0, 1. So if I were going to actually go graph this graph would cross my y-axis at the point 0, 1. So that's determining slope and y-intercept from each of those. So now the next thing we're actually going to talk about is, if you move down, is we're going to be able to determine if slopes are parallel, perpendicular, or neither. So again, when we're comparing all of these, we need to clearly see what the slopes of our lines are. So again, that's why in these problems we still need to go to slope-intercept form in order to see clearly what the slopes on each are. So again, if it's parallel, they're going to have the same slopes. If it's perpendicular, that's where we're going to have that opposite reciprocal. Pendant right there. So I'm going to have opposite reciprocal on these. And if it's neither, then it's just not going to be either of those. So for example, if we look at 18, both of these are already in slope-intercept form, so I don't have to do any work there. And from here, all I have to do is look at my slopes. So I say my first equation, well, that has a slope of 2. And my second equation also has a slope of 2. So like we said before, if they're the same, that's how I know that these are actually going to be parallel. So 19, again, they are already in slope-intercept form, so I don't have to do any work there. So now I compare my slopes. So this one has a slope of 2. Right away, I can see that my second slope is not parallel because it's not the same as this one. So I have to do one more step. So to find the opposite reciprocal, you can pick either one. So I'm going to look at 2. So 2, what's the opposite reciprocal of 2? Well, if we take the opposite of 2, that's going to make that a negative 2. And now I need to flip it because that's what the reciprocal parts mean. So I need to actually flip it. So instead of being negative 2 over 1, it's going to be 1 over negative 2. So this slope is what I compare. So is 1 over negative 2 the same as the one in my other equation? In this case it is, so that's how it tells us that this is actually perpendicular. So those two are perpendicular. Now in 20, unlike in 18 and 19, the second equation is not in slope-intercept form. So I actually have to put it there first. So in this case, I'm going to get y by itself. So I'm going to subtract 3x from both sides. And you should be left with y equals negative 3x minus 3. And this is the point where, again, we compare our slopes. So right away on my first equation, I have a slope of 1/3. And on my second one, I have a slope of negative 3. So again, on this one, since they're not the same, I can immediately say that they're not parallel. And this is where, if you're getting good, you can kind of see. So if I flip 1 over 3, that's going to be 3 over 1. And then if I make that negative, that's going to make this a negative 3 over 1, or just a negative 3. So this, if you notice, is the same as the one in my other equation. So this one, again, is also going to be perpendicular, because the slopes are opposite reciprocals of each other. So for this next one, this one's a little more intense because both of my equations are not in slope-intercept form. So to get there, for that first equation, we have 2x plus 4y equals 8. And I want to get y by itself to do that. So to do that, I'm going to get rid of my x terms from both sides. I'm going to be left with 4y is equal to negative 2x plus 8. So then my last step is going to be dividing by 4. Since we're multiplying by 4, we have to undo multiplication by using division. And we're left with y equals negative 2 over 4. Well, that can reduce because 2 goes into both of those. So a negative 2 divided by 2, that's going to be negative 1. And 4 divided by 2 is just going to be 2. X. And then my last part is 8 divided by 4, which is just 2. So in this case, the slope of my first line is negative 1/2. So now I need to find the slope of my other line. So this one is really close. The only thing I have to do to get y by itself is divide everything by 4. Then I'm left with y equals, again, negative 8 over 4. That's going to be a negative 2. And then 16 divided by 4 is just 4. And that's a negative 2x, minus 4. So in this case, so the slope of my second equation is going to be negative 2. So if I compare those, negative 2. So if I didn't know what my second one was, if I take negative 2, I want to know what's the opposite reciprocal of that. Because right away we can tell that they're not parallel to each other. So the opposite reciprocal of negative 2, well, the opposite of negative 2 is just 2. And this is really 2 over 1. So when I take the reciprocal of this is going to be 1 over 2. So again, guys, now this is where we have to compare this to my one and my slope of my other equation. So then I say, okay, well, are these equal? Well, in this case, 1/2 does not equal negative 1/2. So since they're not the same, and since they're not opposite reciprocals of each other, in this case, these lines are neither. So they're not parallel to each other, and they're not perpendicular to each other. Okay? So this is the end of page 2, and stay tuned for page 3.